We're going to continue to look at exponential functions here in section 6.3. Our previous explorations, if you recall, were f of x equals 2 to the x and g of x equals 3 to the x. Now we want to see what happens when we have an a that is less than 1. So we have 1/2 and 1/3. Okay, so we have suggested here values for x. 1/2 raised to the negative 2 power. What would that be? So you'd have 1 over 1/2 to the positive 2 power. So you'd have 1 over 1/4. 1 over 1/4, 1 divided by a fourth is 4. Okay? You'd have 1/2 to the negative 1 power, which is 1 over 1/2 to the positive 1 power, or in other words, flip it, and you would have 2. And of course, 1/2 to the 0 is 1. And 1/2 to the 1 is 1/2, and 1/2 squared is 1/4. Now remember, this is our growth factor. So this is how f is growing as x is growing. So multiply a 4 times 1/2, you get 2. 2 times 1/2, you get 1, etc. Okay, we saw that before. All right, let's plot these points. -2, +4, -1, +2, 0, 1, 1, 1/2, and 2, 1/4. So here, like that. That's our f of x. Okay, and g of x now, we're going to raise 1/3 to the negative 2 power. So that would be 9. 1/3 to the negative 1 power. That just would flip it, and it would be 3. 1/3 to the 0, of course, is 1. 1/3 to the 1 is 1/3, and 1/3 squared would be 1/9. And also, we are multiplying to get to our next value for y. As x increases by 1 unit, we've multiplied by 1/3, times 1/3, times 1/3. Our growth factor. Okay, let's plot these. -2, +9. -1, +3. Oops. 0, 1, 1, 1/3, and 2, 9. So again, we're in between the x-axis and our f of x here, and then we cross at 0, 1, and come out here or inside of our f of x. Okay. Why do these functions decrease when the graphs in 1 increase? Notice, remember last time they were going this way, they were increasing, but now they're decreasing. What's different is our a is less than 1, and a is always greater than 0. So we have an a that's between 0 and 1. What are the domain and range? Well, the domain, still all real numbers, isn't it? And the range is still the lowest we'll get is as close to 0 as possible, and then positive infinity. So those did not change. Can y equal 0? No. Again, no value of x exists such that y, or f of x, would be 0. We can't ever plug anything in for x to result in a y of 0, or g of x equals 0. Do we have any symmetry? Is it symmetric to the x-axis, or the y-axis, or the x-axis? No. No symmetry. What are the x and y intercepts? Well, because y will never be 0, there are no x-intercepts. And what's the y-intercept? Well, it's the same as it was when we had 2 and 3 here, right? 0, 1. Because any non-zero number raised to the 0 power will give us 1. Do these functions have a horizontal asymptote? Yes. The x-axis again. And its equation is y equals 0. So we see some similarities and some differences by changing a from a number greater than 1 to a number between 0 and 1.